So after you've learned about variables and their types, now we can learn about how to use them in practice, in some syntax. After our variables and mathematical operations, we can go into if-elif else statement. You are probably familiar with that. It's a logic statement, and we also will learn about some comparison and logical operators that Python uses. So if we want to check some condition, and if it's true, then do some statement block, we can use this part of code. If our condition isn't true, then it goes to this line and checks if condition test2 is true. If it's true, then we go to statement block number 2. And if test1 and test2 conditions are not right, then we're just doing else, code 3, and Python executes statement block 3. So mainly we will use on our course just if, this part of code, or if plus else. Elif, I haven't seen some examples where it can be used in practice. But if we understand what we can do in statement blocks, we can do some printing, doing some mathematical operations on variables, which we've learned. How to write condition test1 or test2. For this purpose, Python has several logical operators, and to understand them, we can use some table of true or false. For example, Python has first operator is not something value. A is a Boolean value. From its name, it's very obvious that if we can construct such table, A and not A. In this table, we can clearly see what happens if A has some values and what will happen with not A. So first of all, we can write true. From its meaning, it's obvious that not A will become false. So if we have, for example, not A is equal to 2, not is bigger than 2, then this means that A is smaller or equal to 2. And if we have some false A, then it will become true. In order to have to keep this table neat and tidy, we can create such replacements for true and false. Let's call true 1 and false 0. Why do we have these replacements? Because in Python, actually, you can, instead of true or false, you can write zeros and ones. And Python will understand that it's not an integer, 1 or 0. It will understand that it's a Boolean value, true or false. And following these replacements, we can recreate our table like following. 1, it becomes 0, 0, and 1. Pretty clear. So I will put this table there. The second logical operator is AND. It requires two Boolean values. Let's call them for consistency A and B. This operator is always is true only when A is true and B is true. Otherwise, it will be false. Even if A is false, or B is false, or they both are false, it will be false. So we can write down table like this: A, B, and now instead of two possible outcomes, we can have 4 possible outcomes, because A can be true or false, and B can be a true or false. And by laws of combinatorics, we'll get 2 multiplied by 2 is equal to 4. So A and B. If A is false and B is false, and is obviously false. In the same manner, they are false. And finally, only if they are both true, an AND will give you true. The final operator which is used in Python is OR. A or B. It's true only if A or B is true. That means that it's false only when A and B is false. And we can write down the same table, but with different values of zeros and ones. A or B. Nor A nor B are true. That means that OR is also false. A is true. That means true or false. True. We have one true. That means that OR is already true. The mirror case. And finally, if both A and B are true, then OR is still true. These operators can be used to create quite complicated conditions, and now I will show you how to create this. We can combine these conditions to get more and more sophisticated. For example, we can write like that: or not B and B, D and C or E. So we can write. We can stack them together in order to get something what we want. And if you want to write full condition, then you need to put it in brackets in order for Python to recognize it. And also, it's probably better to put brackets on every single logical operator, but you can, in some cases, you don't need. For example, if you A and B and C, you don't need to put brackets here and here. You don't need. It's the same as A and B and C. But to not confuse yourself and to you don't want to remember which statement is stronger or which is weaker, so you can just write brackets every single time and to be sure. And now I will show you this example of such monstrous conditions in the code. So these are our truth tables, which I wrote, and these are comparison operators, which are used in Python. You can check for equality of something, inequality, bigger than, smaller. So these operators are pretty similar to which you have in other languages. And that's how you write something like that. Also, Python has special comparison operator where you can compare if B is between A and C. I haven't known some language, some other language where this comparison operator is, except Python. So if you want to compare if B is equal to A, is between A and C, you can use it. And as you can see, you just write some brackets, and it's very important to open and close brackets at the end of each condition. After condition, you just write down semicolon, and then your statement block begins. If you want Python to recognize your statement block, you need to press tab here. So Python doesn't need brackets and semicolons as C++ needs, but it needs tabs to understand if it's the new part of code which is following some condition, or is it actually a statement block which needs to be done. So you just put tab and then you begin, and every whole statement block needs to be shifted by tab, because if you will not press tab here, then Python will think that that was the statement block and this is the end of the statement block. And now loops. Loops are very common in our course, and we will use them constantly because we will have a lot of numbers, a lot of parameters which we'll need to loop through, and that's why it's very useful. So the very basic loop structure syntax is like that. If you have some A, and A is some list or a string, and if you want to loop through each element of this list or every character of string, then you write down just like that. Then you can separate, start your statement block from tab again. For example, here we run. In this code, we just got our new list, which consists of 4 elements, and then we looped through all of them in order to print them. So we got our A, B, 1, and true. But sometimes it's not very. The structure can do something, because sometimes you'll need index, or for example, if you have some list A, B, C, D, sometimes it's important for you what index this element has, because index starts in Python from 1, 0, 2, 3. For example, you want to want to print only elements whose index is bigger than 3. Then you can't do it but by just looping through the list, and you'll need another structure. For that structure, Python has special function which is called range. And range creates a list. Creates a list of numbers, which can be used a list of indexes you can loop through. So how range works? For example, you want to get list of 0, 1, 2, 3, n. This is and 4. And you have 5 elements here. This is the most basic use of range, and you just write down range 5. That means that this list will start from 0 and it will have 5 elements. Or alternatively, it will end at number 5, it will stop there, and it won't print any numbers in that list. And using range, you can now rewrite your loop like that. For e in range, for example 5, if we take, where e is index of that array, we can print. We can now put colon. This is tab and print a square brackets e. Now this code will do the same the previous code did, but we can get now index. So we can then print our index e. And if, for example, in that example where we wanted to print out only index elements with index 3 or bigger, we can write like that. If e is bigger or equal to 3, then print a e. So like that, and with range we can do this example. Range can have other arguments. For example, if you want to, its general form is ind minimum index, maximum index, and step. Minimum index is index from which list which range will create starts. Maximum index is index which will stop creating the list and it won't be included in the list. And step is difference between elements of each array. For example, if we take range 1, 5 with step 2, we will create list which starts from 1, then 1 plus 2 is 3, then 5. 5 is a stop number and it won't be included in this array. So we will just end up with this list. And now let's see other examples of using array created by range in code. So this is example I've talked about, and why we can write only one number and range will still understand us. By default, this value is equal to 0. So if we aren't writing then it will start from 0, and step is by default is equal to 1. So in that case, it will start from 1 and 8, and step will be 2. At that case, it will start at 1, and will be 8, and step is 1. And in that case, it will start from 0 and end at 8, without including 8. So as you can see, here's 1, 3, 5, 7. And in the last one, comparing to this one, there is 0 at the end. And now we don't need any arrays to create, and we can just loop through array created by range, and do something else like that. If we want to, in that example, we are adding to the end of the string, we are adding character we, which will end up in that string. So first of all, we print out every single index, and in order to get common with range, and then we get Yuri. If we want to create nested loops, to loop in loop, we can use this syntax, and if we want to add another loop, we will just press another tab, and we can stack them together. It's useful sometimes if we are using two-dimensional lists or even bigger. And this particular structure, you will remember it, and it will be really useful in the latest parts. Now sometimes it's useful to loop with condition, because we don't know where to stop, and we don't know exact number of loops we want to create. So that's why we were using while condition, and without any indexes or ranges, it will just do. It will just loop after over and over while condition is true. When condition is false, then loop won't be executed. Another possible way to create loops with condition is without previous loops. For example, for e in range some big number, very big number, and then we can use if condition, then break. Break is a special keyword, and after we print it, then the whole loop is broke. And if we use break with some nested loops, for example with two loops, and after we break, we write down word break, it will break only first loop, but not the second one. The second one will still work, and then we just can do something. Both methods have the advantages and disadvantages, because as I said before, while condition you will need to add additional line in order to get index. You just cannot get index just from condition, and in that case the main disadvantage is that we don't know the sufficiently big number. We can be mistaken, and then the loop will not give us true result because it won't loop enough time. And now let's compare the speed of both. Let's compare the speed of both ways of looping with condition, because firstly I've read in some articles that for loop is much faster than while loop, and that's why I wanted to prove it. And now let's check this. So now we run our operation. This is some time-consuming operation in order to get a time of working of while loop and time of working for loop. Each loop is working in the same with the same algorithm, so we are doing a little experiment. And as you can see, star in brackets disappeared. That means that our code stopped working because it's done. So for loop needed 5 and 8 seconds, and while loop is clearly faster, but not very much, like on 20%. It's not a big difference, and it probably is affected because of for loop with condition has if statement, which requires some time to process. Because it can be so that if while or for statement block is very big, then if statement won't take so much time, and in that case for loop can outfast while loop. And you can toy with this code and do whatever you want and get your knowledge and perspective. And well, you can now make your own conclusions and your own simple programs. And here are some practice tasks for you for the next lesson. So I'll give you some three, as I remember, 3 practice tasks, and you can do them. Here are the tasks itself, and here you can do the code. And I will check it because it's very important for me. And some useful links. If you still have some questions, you can always write me on mail, but you can firstly go to some useful links, like these are 2 very good and complete tutorials in Python, and this one is particularly good because it allows you to play with code at the same time in browser, the same as Jupyter Notebooks allows you. So if you have some questions, just write me down, and that's all. And the last one, I will tell you when the next lesson will start. It will be in 2 weeks at the same time, at 28, 10. Oh, as a matter, 28th of October. That's it. Bye-bye.
Thank you very much.